So here's what we just did. We changed the query that we are going to use in order to pull data, and we then gave that query a spin. Let's now do something a little more complicated. Let's set up a processing pipeline in Dataflow. If you're not familiar with Dataflow, well, that's a topic unto itself, and we are not going to spend a whole lot of time discussing it. But at a very high level, you can think of Dataflow as a pipeline architecture in the Google Cloud Platform. Dataflow is based on Apache Beam, and Beam, by the way, is meant to be a portmanteau of the words batch and stream. And the great attraction of Dataflow is that it allows us to set up pipelines for both streaming data and batch data, and to do so in a platform independent manner. We write code to set up a pipeline. That code looks very much like Spark, and we can write that code in either Java or Python. We can then go ahead and execute that code on a different runner, on a runner of our choice. We could, of course, choose a Dataflow runner which will execute it on the Google Cloud. It is also possible to specify runners for Spark, Flink, and various other open source platforms as well. So that's what Dataflow is. Let's now plunge into a use of Dataflow where we will take data from BigQuery, set up a pipeline which will go ahead and write it to cloud storage, that is to buckets, that is blob storage on the Google Cloud Platform. Those files, which are going to be output from Dataflow, will then serve as the input into our TensorFlow model in just a little bit. As the comments in the code here tell us, we could have read directly from BigQuery into TensorFlow, but it makes sense for us to use this pipeline where the data comes from BigQuery, is processed in Dataflow, and is then written to Google Cloud Storage and then picked up from Google Cloud Storage by TensorFlow, just because this is going to more practically mirror our real world use of such machine learning models. With that long preamble out of the way, let's plunge into the code. This pipeline is going to take quite a while to run, by the way. It has a method called toCSV. So this takes in a dictionary corresponding to one row of the input data from BigQuery, and it returns just one string with all of the values in that row separated by commas. If you're wondering why it takes in a dictionary, well, that's simply because Dataflow is going to make use of dictionaries, and that is how the data is going to be handed to us when we read from the BigQuery connector. More on that in just a moment. But this method that you see highlighted now, the toCSV method, is basically a helper, and it's going to return one string with comma separated values. These can then be written to our CSV files. Okay, let's now turn our attention to some of the pre-processing before we set up the pipeline. Dataflow requires various options such as a staging location, a temp location, and so on. This is because Dataflow can be thought of as a completely auto-scaling execution engine. Our code and our data storage are separated from each other, and the Google Cloud Platform will take on the responsibility of assigning as many nodes, that is, as much compute capacity as is required. This is why Dataflow is considered today's version of doing big data. It is a step up from Spark or even from Hadoop, in which the storage and the compute are inextricably tied to each other. A common way to use Dataflow is to take in some properties such as these options, such as the choice of the runner, from the command line. In this instance, though, we are not going to take those in from the command line. We will simply specify those from within our code. That code will be coming up in just a moment. But even so, this is pretty common in Dataflow code. We take in a bunch of options. Those options are then used to instantiate the pipeline object. Notice that that is the call to p equal to beam.pipeline. Notice once again how we specify the runner there. And that runner in this instance has been passed in as an argument to our function. If we wanted to run this locally, we could specify a local runner. If we wanted to run this on the Google Cloud Platform, we'd specify a Dataflow runner. We could also choose to specify runners for Spark, Apache Flink, and so on. Okay, coming now to the heart of this pipeline. This is the for loop which actually creates the pipeline. Notice that within this for loop, we are creating two separate pipelines for the training data and the validation data. The result of this will be to write out the training data to one Google Cloud Storage location and the validation data to another. That's why we have this particular for loop going on. Later, when we submit this job for execution on the Google Cloud and we examine it from the console, we will see two parallel pipelines, one for training and one for validation. Okay, let's move into the body of the for loop. We execute our query. This is going to simply give us back all of the data. We then create the output file. This is the Google Cloud storage location. And now this highlighted bit of code really is the heart. This is the pipeline itself. Notice how within the pipeline we make use of the pipe operator. This is an overloaded operator in Python, which is used to apply specific steps, that is transformations, and chain together these transformations into the pipeline as a whole. Dataflow uses a data model which is not that different from TensorFlow. It relies on directed acyclic graphs. In those graphs, the nodes are the transforms. Those transforms correspond to the functions that you see highlighted on screen now. And the data that flows between those nodes, that is the edges in our directed acyclic graph, these are P collections. These are specific collections which can be unbounded in Dataflow, and they correspond roughly to tensors in the TensorFlow world. So it's really no coincidence that TensorFlow and Dataflow have pretty similar sounding names. And in case you're wondering what the strings are, those strings like read and toCSV and write, well, those are just descriptive names for the individual transforms within our pipeline. Once again, this is pretty similar to the TensorFlow way of doing things. So in any case, now that we've defined our pipeline, it consists of three steps. The first of these reads from BigQuery, making use of the beam.io.bigquery source. That's the connector between Dataflow and BigQuery. The second of these applies the toCSV helper method, which we just discussed a moment ago. This application is done using the beam.map method or transform. And finally, the output of the two CSV functions are written back out. They are written out to a text file. And what text file is that? Well, it's the one defined by the out file variable, which once again we defined right up top.